Hey guys, welcome back to the channel. At last we are back for the fourth and final episode of the Bubble Nebula Project video series. So far, in part 1, we've covered the equipment used to acquire the data and how I set up my sequence in Nina using the advanced sequencer. In part 2, I talked about my pre-processing workflow. In part 3, I showed you how I post-processed the nebula in SHO. And in this fourth and final video, I will show the post-processing of the RGB stars and how I blend the stars with the nebulosity. I will try to go through all the steps slowly so that you can all follow along, but I have also created chapters so that you can easily skip to the parts of the video that interest you the most. Alright, let's get started. In this step, let's open one of our images, which contains the stars. And that's one of the images that we obtained at the end of the second video in this 4-part video series. So what we want is only the stars. We want to remove all of the nebulosity. So what we're going to do is we're going to use the StarNet process to extract the nebulosity. So first, let's clone this image. And then let's go ahead and run the StarNet process. And here's our Stardust image. So what we want to do now is we want to use the Stardust image to remove the nebulosity from the image that contains our stars. And this way we will be left with only the stars. So for this, we're going to use a pixel math expression. But first, let's rename these images. So the image that contains our stars, I am just going to name it stars. And our starless image, I am going to name it starless. All right, so let's open pixel math. And the expression that we're going to use looks like this. So we're taking the inverse of our stars image, we're dividing it by the inverse of our starless image, and we're taking the inverse of the result. So let's go ahead and apply that to our star image. And we obtain this. So now we can maybe reset the STF to get a slightly more pleasing result. There you go. So as you can see, we only have the stars. So the same operation needs to be done for all 3 channels. I've completed the process and saved all 3 images on my hard drive, and you can see them here. One thing that you might notice right away is that the larger stars in the blue image are quite a bit larger than in the green or the red image. And this is due to the fact that my refractor is not truly apochromatic, especially in the bluer part of the spectrum. So when we do the color combination in the next step, this will cause some problems. We're going to have some really bad looking blue halos around the larger stars. So what we'll need to do is we'll need to shrink the larger stars in the blue image first before we can do the color combination. So let's do that next. To reinforce the point that I just made in the previous section, I did a quick color combination of my RGB stars, and then I ran photometric color calibration. And then I zoomed in on a small group of stars, and you can see that the larger stars all have a blue halo around them. And that is definitely caused by residual chromatic aberration on my refractor. So we're going to mitigate this by shrinking ever so slightly the larger stars in the blue channel before we do the color combination. Let's do that next. In order to shrink only the larger stars, we need a way to target them. So we need to create a mask. So let's start by cloning this image, and we will rename it mask so we can identify it. And remember that this image is still linear, so let's remove the STF. And now we're going to apply a histogram transformation. And what we're going to do is we're going to stretch this image, but we're going to clip the blacks, and that will allow us to only reveal the brighter stars. There it is. So now the next step is that we want to enlarge those stars, because otherwise our mask will not cover the entire halo of the stars that we want to shrink. So let's use the morphological transformation process. And we're going to use the dilation operator, 3 iteration, and let's apply that. All right, so now, as always with a mask, I like to apply a light convolution to soften the mask a little bit. And now we can apply our mask to our image. And we can verify that the mask actually covers the entire halo of the stars that we want to shrink. All right, so now we're back to morphological transformation, but this time we're going to use the erosion operator. And let's lower the amount to 0.55, and we'll apply that. All right, so the effect is subtle. Let's zoom in and see before, after, before, after. All right, so now let's test this out by doing an RGB combination. So now we can apply the same STF to our image, and then we can compare that to our original image and see the impact. And there it is. So as you can see, this image looks a lot more natural, and we really reduce the influence of that chromatic halo that surrounded some of the brighter stars. So I think this is successful and the image looks good. So let's continue. At this point, we want to run the photometric color calibration tool in order to apply the right white balance to our image. So the first thing that we want to do is click on search coordinates, type the name of your object, click search, and get. Make sure you have the right focal length set up and the right pixel size, and then apply the process. And once the process is completed without any errors, don't forget to save this image. I named it stars here, and this will serve as the starting point for the next steps. Let's go ahead and stretch our image using the histogram transformation process. So let's reset our zoom and open our preview window. And let's stretch the image like so. So remember that because we removed the nebula, the sky background actually has a value of 0. So you don't want to move, you don't want to clip the blacks here. So just move that one, just move the midtones. And that looks pretty good. And then apply that. And then you can save this image and we'll use it in the next step. Emphasize only the larger stars. And so again, we need a way to target them. So we need to create a mask. So let's start from our image and let's extract the luminance. All right, and then what we want to do is we want to show only the brightest stars. So again, we can use histogram transformation for that. And let's do this. And that looks pretty good. Simple enough, let's apply it. So now we're going to again use morphological transformation to enlarge our stars. So let's see, we're going to use 3 iteration, operator dilation, amount 1.0. Let's apply. There you go. As always, a light convolution to soften our mask. And now we can apply our mask to our image. Let's take a look. All right. So now again, morphological transformation, but this time we're going to be using the selection operator. And let's see, mount 0.8, selection 0.2. And then let's apply that to see what we get. All right, let's see, before, after, before, after. That looks pretty good. We can try to maybe increase the amount just a little bit more. Before, after, before, after. Yeah, perfect. That looks great. Let's bump the saturation just a little bit. So we're going to use the curves transformation process. Let's open a preview. Let's zoom in a little bit. And we're going to move the saturation slider ever so slightly. It's very sensitive. So I think that looks pretty good. Maybe a little bit more. Let's see. Before, after, before, after. Okay, it's subtle, but the effect is there. So let's apply it. All right, so now we are ready to blend these stars with our nebula. And we're almost done. So I've opened the nebula image that we obtained at the end of part 3 and the RGB stars image that we just finished processing, and we are going to blend them together using pixel math. So the expression that we're going to use is a pretty standard expression that you will find on the internet. And so we take the inverse of our stars and we multiply it by the inverse of our nebula, and then we take the inverse of the result. Let's select create new image, and then let's drag and drop this to one of the source images. And here is the result. Absolutely gorgeous. A lot of details. The star colors shows through. That looks great. And so with this, we are done. Alright, so we've reached the end of this video series. I hope that you found it helpful. I would like to recommend one more time a great resource to learn more about astrophotography image processing, and it is a book by my friend Rogelio Bernal Andreu called Mastering PixInsight. Very highly recommended. Alright, so please click like and subscribe to the channel. We will be coming back in a few weeks with another video, and until next time, thank you for watching.